Very good morning, students. I am Praveen, mathematics lecturer. I am here with chapter number 8, applications of integrals. Applications of integrals. The last class we have discussed uh, integrals. We completed that chapter, and today we are starting this first class of application of integral. Integral is used to find the areas of the curves in the coordinate geometry. We are finding the areas of the curves. Okay, here we'll discuss how to find the area of the curves if the curve equation is given. Introduction. The process of finding area of some plane region is called the quadrature. Suppose we have a plane quadrature, means we have a curve in the plane, means x and y axis. Together it is a plane, and if we have a curve in the plane, then we are finding the area of the plane, area of the curve, and finding the area of curve in the plane is called quadrature. In this chapter, we shall find the area bounded by some simple plane curves with the help of definite integral. So using the definite integral, we are finding the areas of the curves, and for solving the problems on quadrature easily, if possible, first draw the rough sketch of the required area. Suppose we are finding area of any curve, we should draw a rough diagram of that curve first, and then we come to know which area we are going to find. And if you draw that diagram, then only you able to find the area of curve easily. Without diagram also you can find, but you must have that much of knowledge. Okay, then only you can solve directly. But if you draw a diagram, then you easily you can solve this kind of problems. Okay, now we are discussing the different types of curve and how to find their areas. The first area bounded by the curves, how to find that the area bounded by certain curve y equal to f of x axis, and the ordinate x equal to a and x equal to b is given by. Suppose we have a curve equation y equal to f of x, and that f of x area we are finding with x axis. F of x y equal to f of x is a curve equation. Curve and x-axis, and on x-axis not infinite area, we are finding the area from x equal to a to x equal to b. Then the area become integration from a to b y dx, or integration from a to b f of x dx. So if we draw this diagram, curve diagram, then easily we come to know that this is y equal to f of x curve, and this line is x equal to a, and this line is x equal to b. On integration, applying upper value and lower value, I mean definite integral formula, will get the area from x equal to a to x equal to b. So this is the first type of area of the curve. Now we are saying the area on y-axis. The previous area, you can see that the shaded area is on x-axis, means area bounded with x-axis. Okay, here the second type, you can see that the area bounded with a y-axis. If a area is bounded with y-axis, the given function become x equal to f of y. The curve equation is x equal to f of y, and y-axis bounded with the y-axis, and the ordinates are what? Y equal to d, y equal to c to y equal to d. C to d area we are finding. Understood? So this is what the area that we are finding. Next, symmetrical area. Symmetrical area. The symmetrical means here the x-axis or y-axis, above x-axis, below x-axis, or right of y-axis, left of y-axis will get the same area. Then x-axis and y-axis become the symmetric line. In that case, how to find the area, so that we are discussing. If the curve is symmetric about the coordinate axis or a line or origin, then we find the area of one symmetrical portion and multiply it by the number of symmetrical portion to get the required area. For example, we have a curve that is y square equal to 4ax. This is a parabola curve, and this graph is what? This is the graph, and we are finding the area. We are finding the area from x equal to a to x equal to b. We are finding the area. Okay. Then here this x-axis is the symmetric line. Above x-axis and below x-axis we have the same area. Above x-axis, below x-axis, we have the same area. If you calculate the area from A to B, we will get a above x-axis area. Will not get below x-axis area. If you're finding the area which is in both quadrants, then you find one area and multiply it by 2. If you multiply it by 2, then we'll get the total area, which is in the first quadrant as well as in the fourth quadrant. By the definite integral, we can find the above x-axis area only, not below x-axis. If you want the below x-axis area, then you multiply by 2. Okay, now for example, we have a ellipse. We have an ellipse and we are finding the equation of the ellipse. Then using the definite integral, we can find only the first quadrant area. The area is from 0 to a. 0 to a. If you find the area from 0 to a, you will get only one portion area. Here this diagram having a both symmetrical line, x-axis symmetric line as well as y-axis symmetric line. Above axis is same area, same diagram. Below axis also same diagram. The x-axis is a symmetric line, and y-axis right side as well as left side we have a same diagram. It means y-axis also symmetric line. Then we are getting 4 portions here. We are getting 4 portions. If we calculate one portion area and multiply it by 4, we'll get the total area. We'll get the total area. That is 4 times 0 to a f of x dx. Okay. So if you draw the diagram, then easily you come to know that how many portions we're getting to find the area. Okay, you find one area multiplied by 4, you will get the total area. Suppose we are finding only above x-axis area, then you multiply by 2. Okay, so in this way we are calculating according to the given question. So that is mentioned here. Suppose you are finding the area of the curve which is symmetric about the coordinate axis or a line or a origin, then we find the area of one portion, and we will multiply by the number of symmetric portion that we get in the diagram. Clear? Next, the positive and negative curve. Positive and negative curve. Suppose we have a positive and negative curves here. The area always taken as a positive. For example, we have a curve equation of sin x curve equation, or a sin x curve diagram is like this. We have an area above x-axis as well as below x-axis. If you calculate the area from 90 degree to 180 degree, 90 degree not 90 degree, 180 to 360 degree, you will get area is negative. But area never be negative. Area never be negative. So we'll take always positive area. Here area is always taken as a positive if some part of the area lies in the positive side, that is above x-axis, some part lies in the negative side, that is below x-axis. The area of two parts should be calculated separately and then added their numerical values to get the desired area. Means to get this area, we're finding this positive area separately and this negative area separately, and taking positive value of the area and adding together, we will get the complete area. Or else, suppose our curve is like this is y-axis and this is x-axis, and this is our curve, or this is our line. We are finding the area, we are finding the area from x equal to minus a to x equal to plus a. Okay, so we have some portion here which is below x-axis. You find this area separately, but definitely this area we will get negative. So you take its modulus, then you will get it positive area. Suppose this area is 2 square units. Okay, and the remaining portion, you can see that here this is above x-axis. Definitely this area we will be will get a positive. Okay, and on suppose this area is 10 units, 10 square units, the total area of shaded region become 2 plus 10, and it is equal to 12 square units. So like this we are finding the area. Suppose if you are getting this area minus 2, then you take its modulus, that become plus 2, and this area is 10, then the total area become 2 plus 10, it is equal to 12. Means negative portion area we should find separately, and taking modulus, that become plus area. If you take together, then you won't get a complete exact area. You won't get exact area here. So that's why we have to find the negative area separately, taking its modulus, that become plus, and finding positive area separately and adding together, that become the total area. Understood now? So that is mentioned here. Next, area between the two curves. Area between the two curves. You can see that in this area, in this diagram, we have two curves. One is a to b above, and another one is a to b below. We required an area between these two curves. Then you find upper area value, and then you find lower area value, and subtracting these two area, you will get the area between the curve. Suppose you are finding the area above, okay, then you will get area from a to b, completely this much you will get. Okay, complete a to b to below, up to x-axis you will get. If you find the lower area, it means from AB below curve to lower side. If from upper side you are subtract the lower side area, you will get the remaining shaded portion. Okay, so that is what area between the two curves. First you find the upper area, and then you find lower area, and subtract these two area, you will get area between the two curves. Understood? Okay, next. We have two continuous areas and different curves. You can see that this is a what it is, a bended curve, and this one is straight line. We are finding the two areas. Okay, here the first area is from a to alpha, and that is y equal to f1x, and another area starting from x equal to alpha to x equal to beta, that is the straight line area, and that is y equal to f of 2x. Here this is not a area between the two curves. Here area of two curves, one after another. When we are getting a area one after another, then we are adding the two areas together, we'll get the complete area. So area of the first curve y equal to f1x plus area of the second curve y equal to f2x, that become the area of two curves. The previous was area of one curve below the another curve. Area of one curve below the another curve, but it is area of one curve after another curve. Okay? So that is we are adding here, and that we are subtracting. Next, we will move to the next topic in this application of integrals. Here, one example is given: area bounded by the curve y equal to sin x. Y equal to sin x between x equal to 0 to x equal to 2 pi. Okay, this is a sine curve from 0 degree to 2 pi. Okay, sine 0 degree is 0, sine 90 degree is 1, sine 180 degree is 0, sine 270 is minus 1, and sine 2 pi value is 0. So we are finding the area from 0 to 2 pi. But we have some portion of this sine curve above x-axis as well as below x-axis. Then we are finding both areas separately. Above x-axis and below x-axis, both areas we are finding separately, and we're adding together. Of course, above x-axis area will be always positive and below x-axis area will be negative. But below x-axis area, if you take it modulus, then definitely we'll get a positive area, and adding together we'll get the complete area. The area of this sin x from 0 to 2 pi, one portion becomes 0 to pi, another portion becomes pi to 2 pi. 0 to pi is y dx, and pi to 2 pi I'm taking minus. If we take minus y, area become plus. Okay, area we will get negative. If you take previously minus, the minus into minus, that become plus, or else you take modulus of the second area. Okay, if you're not understood taking minus here, you take a modulus, definitely you will get a positive area. Previously, if we take minus, area comes negative, minus into minus, it become plus. Clear? So that's why here take a, first one is plus y dx, second one is minus y dx. This is sin x and this is minus sin x. Integration of sin x is cos x. What is the integration of sin x? That is minus cos x, and integration from 0 to pi, and minus integration of sin x is minus cos x, and it is from pi to 2 pi. You can take this minus outside, that become minus outside, and taking cos pi minus cos 0, upper value minus lower value, minus into minus, that become plus, and upper value is 2 pi, cos 2 pi, upper value is 2 pi, then it is cos 2 pi, and minus cos 0. This is equal to minus cos pi value is minus 1 and cos 0 value is 1, minus cos 2 pi value is 1 and cos 0 value is 1. This completely becomes 0. And what is minus 1 minus 1? Minus 2. Minus 2 into this minus, it is plus 2. 2 square units. 2 square units. Why we have taken here minus? That is of this minus, na? Pi to 2 pi, pi to 2 pi. Okay, we have taken different pi to 2 pi, na? The upper value pi, this is okay. The cos pi value is minus 1. Already we have here minus, minus into minus, it become plus, plus 2, and this is what plus symbol. 1 plus 1 is 2. Here minus 1 is plus minus 2 into this minus plus 2. 2 plus 2 is 4 square units. It is 4 square units. I'll explain once again. This is minus cos x, and it is from 0 to pi, and this minus y minus taken outside, and sin x integration is minus cos x. Okay, and minus into minus, that become plus. First I am taking upper value, that become cos pi, then I am taking lower value, that become cos 0. Upper value minus lower value. Minus into minus is plus, upper value is 2 pi minus lower value is pi. I have taken previously 0. That is not 0, we have to take pi. Okay, now what is minus outside as it is? Cos pi value is minus 1 and cos 0 value is 1, but behind that we have minus symbol. Minus into minus, minus 1 into minus 1 is minus 2, minus into minus is plus, plus 2 it is. Okay now, and cos 2 pi value is 1 and cos pi value is minus 1, but behind that we have minus symbol. That's why minus into minus is plus. 1 plus 1 is 2, and 2 plus 2, that become 4 square unit. In this way we can find the area from 0 to 2 pi. Okay, next. Okay, from here our question starts. Find the area of the ellipse x square by a square plus y square by b square equals to 1. Suppose this is a case of area of ellipse. Area of ellipse formula, you remember that is pi ab. What is the area of the ellipse? If you remember, area of the ellipse is pi ab, then easily in one step or directly you can take the second option is correct. Suppose you don't know the area of the ellipse is pi ab, then you need to solve this problem. I'll tell you how to solve this by integration. What is the curve equation here? X square by a square plus y square by b square is equals to 1. Let us write this curve as a y equal to f of x form. Then I'm writing y square by b square LHS as it is, taking this x square term to RHS. This become 1 minus x square by a square. On taking LCM, a square is the LCM, numerator become a square minus x square. And taking this b square to RHS, this become y square equal to b square by a square into a square minus x square, and y equals to, we will get b by a into root a square minus x square. This is curve equation. This is the curve equation. And what is the diagram of the ellipse? I'll draw that ellipse here. This is the ellipse diagram. This is x-axis, y-axis. This is the origin. From origin to A. Origin to A will get only one area. Using this curve from 0 to A will get one area. If we multiply the area by 4, we'll get the complete area of the ellipse. Then area of the ellipse become 4 times 0 to A. This kind of portions, we have 4 portions. We are finding one area and multiplying by 4, we'll get the complete area of the ellipse. And one portion is y dx. And what is y curve? B by a. That is b by a under root a square minus x square dx. This become 4b by a, and under root a square minus x square dx formula is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a. This is integration of a square minus x square dx formula. Now first I am substituting the upper value. What is the upper value here? Upper value is a. Upper value, if you take a here, a square minus a square, it becomes 0. 0 into anything, it becomes 0. This first term becomes 0. The second term is a square by 2. If you take x equal to a, this become a by a is 1. And what is sine inverse 1 value? That is pi by 2. Minus lower value. If you take x value is 0, 0 into anything is 0. Minus, if we take x equal to 0 here, 0 by a is 0, sine inverse 0 is 0, the last term is also 0. So this becomes 4b by a into a square pi divided by 2 to the 4. This 4 cancel, and this a, 1a get cancel, remaining is pi ab square units. So this is the way that we are finding the area of the ellipse. Here we have 4 portions in 4 different quadrants. We are finding only one quadrant area, and multiplying by 4 we'll get the complete area of the ellipse. Understood? So in this way we are forming first y equal to f of x curve equation and integrating from 0 to A, because this first portion, it is from origin to the vertex A, 0 to A. Then finding one area multiplying by 4. Okay, 4 time area will be pi AB, area is pi AB. That is second option correct. If you remember that ellipse area is pi AB as a formula. Ellipse area is pi AB as a formula, so no need to solve this much. Directly you can take the first option is correct. Understood, students? Okay. Let us move to the next problem. Find the area enclosed by the circle x square plus y square equal to a square. This is the equation of the circle with center is origin. Means its diagram is like this. This is the circle and its radius is r. And what is the center? Center is origin. This is what? Origin and the center of the circle. A square is the radius square, r square. The radius become a. Means we can find only one area from 0 to A, and multiplying by 4 we get the complete 4 portions area. 4 portions area we will get. Okay, you know area of a circle formula pi r square. What is area of circle formula? Pi r square. And what is the radius here? Radius is a, then this become pi a square area. Area become pi a square. Where is the pi a square? The first option is correct. If you remember the pi r square area of circle formula, then directly you can put that pi a square is the correct option. Suppose you don't remember pi r square is area of circle formula, then by integration I'll tell you how to find the area by integration here. What is the curve equation here? Curve equation is x square plus y square equal to a square. Let us write this equation as y is equal to. This become y square equal to a square minus x square, and this become y is equal to under root a square minus x square. Then the area of circle is 0 to a y dx. And what is y? Under root a square minus x square dx. If you calculate this area, we'll get only that one portion area. Like that we have 4 portions. If we multiply by 4, we'll get complete area of the circle. Understood? Let us integrate this. This is equal to 4 into under root a square minus x square formula is x divided by 2 under root a square minus x square plus a square by 2 sine inverse x by a. And what is the limit here? 0 to a. 0 to a we have integrated. The next, substituting first upper value a. If you take x equal to a here, this become a square minus a square is 0. A square minus a square is 0 here. The first term becomes 0. Plus, if you take x equal to a here, this is a square by 2 into a square by a, sorry, a by a is 1, sine inverse 1 value is pi by 2, minus, if we take lower value x equal to 0, 0 into anything is 0, and if you take lower value 0 and sine inverse 0 is 0, 0 into anything is 0. Then this becomes 4 into a square pi divided by 4. 4 cancel, a square pi, or we can write pi a square is the area of circle. Suppose the question is asking find the area of half of this circle, then there is become a square pi by 2, half of this area. Understood? If we are finding the area which is in the first quadrant, then this area is divided by 4. Okay, pi a square by 4 is the area of a circle which is in the first quadrant. So depending upon the given question, we can find the area of circle here. Area of the curve we can find. Let us move to the next problem. Find the area of the region bounded by the curve y is equal to x square and the line y is equals to 4. We are finding the area of the curve y is equal to x square and the line y is equal to 4. So before finding the area, first of all, we should draw a rough diagram of this curve. Okay, let us draw this diagram. Okay, so this is what? This is a x-axis and this one is a y-axis. What is the curve equation? Y is equal to x square or x square equal to y. Whenever we get a x square is equal to 4ay, this is a parabola formula and this is upward parabola. This is what? Upward parabola. X square equal to y is a upward parabola. And there is one more line, that is y equal to 4. So this is a y equal to 4 line. Y equal to 4 line. Then we are finding this area and we have this much of 2 times area. You find one portion area, multiply by 2, we will get the total area of the curve. Okay na? But the shaded portion is on y-axis. Where is the shaded portion? The shaded portion is on y-axis. So we have to take the given equation as a x equal to. The previous two questions, in the two questions we have taken y equal to f of x form. Because the area shaded on we have considered on x-axis. Here the shaded portion is on y-axis. Then we are finding the curve equation as a x is equal to f of y form. Okay na? What is given here? Question, that is y is equal to x square given. We are writing this equation as x equal to root y, yani ki x equal to f of y form. And integrating this, area of the shaded region is from 0 to 4. From origin to 4 it is shaded on y-axis. Okay na? From origin to 4 it is shaded, and this kind of two portions we have. And what is the function here? Root y dy. 2 outside I am writing as it is root y integration 2 by 3 y power 3 by 2 and limit from 0 to 4. This becomes 4 by 3 and taking first upper value, that is 4 power 3 by 2, minus taking lower value 0 power 3 by 2. This is equal to 4 by 3 into we have 4 power 3 by 2. 4 power 3 by 2 can be written as 4 power 1 by 2 whole cube. And 4 power 1 by 2 is square root. What is root 4? 2. And 2 cube is 8. That is 8. 8 4s are 32 divided by 3. Square units. 32 by 3 square unit. Where is 32 by 3? The first option. First option is correct. 32 by 3 square unit. In this way, we are finding the area of this curve. One thing you remember, if you draw this diagram, then easily you come to know that how many portions are there. Okay, from what number we have to multiply. If there are 2 portions, we have multiplied by 2. If there are 4 portions, so we have to multiply by 4. So first you draw a rough diagram, then you are able to find this area. Okay students, today we'll stop here. Okay, we have discussed how many problems? 3 problems. We understood how to integrate, how to find the area of the curve, and we have solved 3 problems. So you run this video very slowly, then you can able to come, you able to know what is the concept, how to find the area, then you are able to solve this kind of problems. We'll stop here. Thank you students.